from the Zero Sum Gains blog. I'm going to give you a quick walkthrough of the two sheets that I linked on the How the Sausage Gets Made worksheet. So the best place for you to start is routine planning. Let's say I want to follow a traditional Shiku routine where it was a squat, bench, squat, so you have repeat movements followed by a bench, deadlift, bench, so you're getting a good distribution. So that's typically a 4-day routine, so you see I have 3 of my 5 days filled out. So if I wanted to have comp bench in here, I would just type it in there, select the movement type there, and then once you type anything in here, you're going to have it automatically generated. So I'm going to fill the rest of these up with comp bench. Now let's say I want to follow generally a linear percentage increase. So here, this is where you manually type it in. So 85, 87.5, 90, 92.5. You could have whatever progression scheme you want. And that would fill in the T1 or primary movements for day 2. Once you have that in, you're going to have to fill out this sheet right here. Now everything so far has been filled in with dummy data, but I'm going to show you what this would look like. Let's say I wanted to do a load velocity, load percent 1RM test. And in this particular movement, which is comp squat, which automatically gets generated once you fill in here, see that's a number 1 movement, that's movement number 1, and it fills it in likewise. Same with comp deadlift, and continues on down the list. Anywhere where there's a blank, this will generate as a 0. So comp squat, let's say I know that my max is somewhere around 102.5. So the typical way you would load that up is, let's say my first one is 40 kilos. So I'm going to do 3 reps of that. And once I measure it out, I'm getting about 0.9 meters per second, give or take. Let's say my next load increase, 3 reps, since it's still lightweight, and then it's giving me about 0.8. Now my next load increase is going to be 60 kilos, or 60% of whatever my 1RM is. So since it's 2.5, that's fairly close to what that is. And this measures out to 0.7 meters per second. Now my next jump is 70 kilos. So because that's a moderate jump, I'm only going to put in 2 reps. I think that's what would be appropriate there. And that clocks me in at about 0.6 meters per second. Now the way this is set up to average, it averages every 3 rows. So if I want to do my next load increase, I need to skip a cell there. So I'm going to skip over here and make this my 80%. Since this is a heavier load, I'm only going to do 1 rep. I can do more than 1 rep, but generally you only want to include your fastest rep. Let's say this one's oddball and it puts me at 0.51. Okay, so that's my general low velocity table. Now this I could have only used 2. That would have been fine. You could purge after the fact, or you could just set it up as 2. So now I have this, the next thing I need to do is I need to conduct a rep to failure set, or an AMRAP. And you could use your cutoff of like when you want to stop your reps to failure, or your AMRAP as when you lose enough technical proficiency that you think that's not useful. Or you could just go with a straight off 1RM and do an actual 1RM. Either way is up to you. But let's say I do a rep to failure and I do it at 75% is what I tend to prefer, and that gives me a MVT of movement velocity threshold, or my slowest rep in that set, usually the last rep, was 0.28 meters per second. Now it gives me an estimate, which is right here, which is about 103.04 kilos. That's good. As you can see, it's filled out the rest of this based off of that. So my max 103 at 0.28 meters per second, 100%. And you look at my numbers here, so I did 40, 50, 60, 65, 75-ish percent. Now the only other thing I would want to do, let's say today is February 19th of 2017, and I happen to complete my rep to failure set the same day, 19/2017. Now as time goes on, when you open this sheet, it's conditionally formatted, so it will turn amber or red if it's too out of date. So as you can see, since it was today, that's perfectly within date. So that's what CompSquat would look like. I've already filled in this same dummy data in all my other sheets here. But what I'm looking to see is that I have a low standard error of estimate, this yellow box, that's low, and I have a high R squared, so this maxes out at 1, and that's a 0.9996, so that's really good. It's also unrealistic, but whatever, let's go with it. So now that I've had all this plugged in, you could see that this table generates off of increments of my percent RM at 2.5%. So if I want to go with something like 98, it's not going to give me that. But if I do 97.5, we'll do that. And if I do above 100%, it's not going to give me a corresponding velocity as well as load. So once I have all this planned out, it's going to plug it in here. So here it'll give me my planned intensity, what that should be on a normal day, and then my prescribed velocity. All I need to really pay attention to is this prescribed velocity and the stop velocity. Prescribed velocity is 0.43, so if I lift 88 kilograms at that velocity, then that's my weight for the day. If I move faster than that, then that means it's a good day and I should increase load. If I move slower than that, then I'm carrying around a little bit of fatigue and I need to adjust on the fly. So I'm going to go ahead, delete all this data here. So let's say I'm doing this as a new set, and I load up 90 kilos, and my fastest rep happens to be 0.52, and my slowest rep happens to be 0.42, and I'm able to crank out let's say 7 reps at that velocity. So you can see here, this tells me what my actual velocity loss is. So that's 19%. If I'm using a threshold of 20 for my main movement, my competition movement, that's good, especially if I'm building strength. Now, if you want to use real time, you have to get as close as you can to this 0.43, I'd say plus or minus 5%, and then you could use this stop velocity. This stop velocity is really just 75%, right, as you can see right here, times 0.75. But you could change that accordingly, so you could tighten the tolerances to 20%, or you could even loosen it, so loosen the tolerances so you could lose up to 30% velocity. That tells you what you want to start near there, and once you go under 0.3 or once you get close to 0.3, you want to terminate the set there. There is some danger in doing this because if you remember in our load velocity table, the slowest I could crank rep out is at 0.28. So this is at 0.3. That's really not that much. Let's see what happens if I make it to 40%. So if I make it 40%, this actually tells me to stop 0.26, which is slower than I could actually accomplish. So this is something to watch out for when you're dealing with higher velocities or higher intensities, is it could undershoot that. Worst case scenario, you could just go off of, do you feel like you complete another rep? And once you start getting upwards into 90% and higher, that's when you kind of want to take that with a grain of salt and just go off of this with delayed feedback. So let's say I complete my next set and I get near the same thing, so 0.52 is an initial velocity, probably not that clean but close to that, and then my end velocity dropped and was 0.4, and I was was still able to squeeze out 7 reps. Velocity loss is 23%, which is a little bit more than is optimal, but I find 25% is still acceptable, maybe even upwards to 30%. So let's say I continue on and I get the same thing. I'll just copy this row here. And then in my last set, I'm getting, I'm keeping the same weight, so 90 kilos. And my initial velocity is 5.2. My end velocity is 0.29. And I still hit that for 7 reps. As you can see, that takes me to 44%. Conditional formatting says, no, that's bad. You should stop there. And then that will tell me that that's a sign for potentially a back off set. So let's say my next set I was 0.75. That puts me at 0.6. And let's say I just did reps until I got to 0.45, and I did that for 10 reps. Okay, so that's one hypothetical setup. Now, as I've been typing away at this, you've seen that this enal set here, or enal value, which is the intensity number of lifts, increases. Now, I'll delete this. You can see how that just dropped. Let me put that back. Now let's delete this. You can see that changed as well. I could also do other things like change the value. You see it drops off. I could lessen the value, and you can see that, let's do 0.28, 0.29. So 2.9 means it's really close to my 1RM, and that intensity number lifts value really shoots up to a point that it's not very realistic. But this gives you an idea of what a good baseline threshold is for the amount of volume you want to hit. It's not just volume, but in volume and the intensity, and it normalizes for both. You could shoot for a minimum training stimulus based off of what you see in the past, or you could go off of the general guidelines. I try to stick between 1.75 and 2.5, usually erring on the higher end. That does mean that you're going to generate more fatigue. Fatigue is a training stimulus, so you want a good amount of that. But you have to do it by exercise. So this is just for a comp squat. If I was doing a pause squat, I would want to have near the same value for whatever I deem to be a training stimulus. Now, if I was doing a comp squat, a bench, and then another comp squat at a lower intensity, then I might be able to equal out the two. But it's all very dependent. Now, if you saw in the other sheet how we were in the routine planning, that this just loads everything in, we left day 3 blank. Well, this is what happens when you leave day 3 blank. But I could just hide that, so we skip straight from day 2 to day 4. And that's roughly how you use this sheet. There's a lot of caveats, but that'll give you basically everything you need to know. And that is how the sausage gets made.